Hey everyone, and welcome to this explainer. Today, we're taking a deep dive right into the engine room of mobile app development. You know, if you've ever wanted to build highly efficient, super scalable mobile applications, mastering state management is absolutely crucial. So today, we're going to completely demystify Flutter state management, and we'll be doing it using the incredibly popular Provider package. But before we even look at a single line of code, let's start with a really foundational question. How does your app actually remember anything? Think about a massive e-commerce app for a second. If your shopping cart, the user's profile, and the product catalog don't have a centralized way to talk to each other, well, your user might add an item to their cart, but the checkout screen simply won't know it's there. An app needs a reliable, organized system to keep track of user data, interface changes, and business logic without dropping the ball. So the crucial point is, state management is the critical architecture behind literally any user application. By definition, it's the process of managing the states of your user interface controls based entirely on your specific business logic. Simply put, it's how your app keeps track of all the data and logic that makes it function as one cohesive unit. Without it, your application just cannot scale or perform well. It's really the glue holding everything together. In this explainer, we're going on a complete concept-to-code journey. Here's our quick roadmap. First, what is state management? Second, meet the provider package. Third, setting up your provider. Fourth, consuming data. And finally, disposing and wrapping up. All right, section 1, what is state management? The foundational logic. Let's think about the old way of building complex apps without a dedicated state management system. You're dealing with heavy workloads, constantly passing data manually down through these endless, tangled widget trees. It's exhausting, right? And ultimately, it delivers a much slower app experience to the user. Now contrast this with the provider way. When using provider, widgets simply listen to changes in the state. That's it. They update automatically as soon as they're notified. This drastically reduces the amount of work the app actually has to do, making everything run so much faster and smoother. Moving right along to section 2, meet the provider package, your state management hero. Okay, let's dive into this. To effectively harness Provider, there's a clear, chronological 5-step practical process we're going to follow to build out our architecture. Step 1, add the dependency. Step 2, create your Provider class. Step 3, wrap your app. Step 4, use a consumer. And Step 5, dispose of the model. This is essentially your master blueprint. Now for the fun part. Section 3, setting up Provider. Let's write some code. To tackle step 1, you'll start right in your pubspec.yaml file. You just add the provider dependency, like version 6.0.3 we've got right here, and run the command flutter pub get in your terminal to fetch the latest version of the package. Simple enough? Once you have it, step 2 is creating your provider class. So you create an abstract class, let's call it disposable provider, and you extend it using ChangeNotifier. Why? Because the ChangeNotifier class gives us the built-in functionality we need to manage state changes and, crucially, to notify any listeners whenever there's a change in your derived classes, like your provider ViewModel. Moving over to step 3, we've got to make this provider available to our entire app. We do this in void main, which, as you know, is the absolute entry point where your Flutter application starts. Here, we use the run app function and wrap our root widget with a multi-provider. And honestly, this brilliantly illustrates just how scalable this package is. Multi-provider lets you manage multiple providers simultaneously for when your app inevitably grows. Inside that, we list our providers using ChangeNotifierProvider to create the actual instance of our provider ViewModel. Finally, we specify child const myApp, which sets the root widget of the application. Wrapping the app exactly like this provides downstream access to your data model for literally everything inside it. Let's move to section 4, consuming data, reacting to changes. Let's move to and see how this builds out when we hit step 4, the consumer widget. Setting up the provider is really only half the battle. Now we need to make the user interface actually react to our data. The consumer widget actively observes changes in a specified provider and then rebuilds its child widget the moment the state changes. Now, when you set up a consumer, its builder callback function requires 3 key parameters. First is the context, which is a build context object that tells you the exact location of the widget in your widget tree. Second is the provider model. That's the actual data object being observed. And third is the child. This child parameter is a reference used for parts of your UI that you want in the widget tree, but you absolutely do not want them to rebuild in response to state changes. It is a fantastic tool for selectively updating parts of the UI without redrawing the whole shebang. Now, what's really interesting about this slide is the distinction between when to use a consumer and when to use a totally different method. As we just saw, the consumer widget is perfect for actively observing changes and triggering UI rebuilds. But what if you just want to update a value, say add a quick item to a cart, without needing the screen to redraw itself at all? That's exactly where you'd use Provider.of with the parameter listen false. This incredibly handy trick allows you to modify the model behind the scenes without triggering a rebuild of the listening widget. It saves precious processing power and instantly boosts your app's speed. And finally, Section 5, disposing and wrapping up. Time to clean up that memory.
Step 5 is disposing of the model. Look, when your widget is removed from the screen and its data just isn't needed anymore, keeping that provider alive in memory is simply a bad practice. You've got to clean up after yourself. By using the @override decorator and calling a void dispose values function, you ensure that the model is properly disposed of right when the widget is disposed. This keeps your application highly efficient and is absolutely vital for preventing memory leaks during prolonged use.
Which leads us to our final takeaway for today. Provider equals seamless state management. Diving into Flutter's state management isn't just some boring technical requirement. It is the key to crafting truly efficient, world-class apps. Provider smooths out those state updates and dramatically boosts your performance. I highly encourage you to use this blueprint to harness it in your very next project. Thanks so much for joining me on this explainer. As you look at your own code today, I want to leave you with a question. Are your widgets working too hard, or are they efficiently listening for the right cues?